Last week, I promised to explain how our experiment works.
Stay tuned next week for a video on how our experiment works.
So that's exactly what this video is. This is the experiment, which is housed inside the rig. The rig is the frame with the nuts and bolts and brackets. It is built to attach the experiment and everything it needs to run to the aircraft. It includes panels that act as secondary containment for the experiment so that if there's a leak, it will stay contained within the rig. Inside of secondary containment is the flow loop. When we picked it up, Daisy and Eric almost cried.
So exciting to see it. I'm like in awe. Actually getting to see this.
Know,
This is so cool.
Yeah, 16 hours straight one day just designing it. There's still lots of time after that, so it's awesome to see it. Yeah.
In the flow loop itself, there are 2 tanks, 5 solenoid valves, 2 pumps, 2 pressure sensors, 2 temperature sensors, and 1 flow totalizer. The tanks are just under a gallon each. The solenoid valves open when given power to allow liquid to flow. The pumps pump from one tank to the next, and the flow totalizer measures how much fluid goes through a section of pipe. We begin the experiment by putting carefully measured amounts of fluid in the tanks. By having 2 tanks, we will be able to test twice as many values. For example, we will put in different amounts of water in each tank and use the pumps to transfer water from one tank to another at different times throughout the flight. This allows us to test the sensors for many different amounts of fluid. On the tank themselves are sensors and actuators. These are sensors and these are actuators. The actuators make the noise and the sensors pick up the noise. Think of the actuator as the instrument, and the sensors are the microphone. The sensor listens and bends based on acoustic waves and then generates electric signals, which is where we get the data. The actuators are what we are using to ping the tanks with white noise, but white noise is not the only sound actuators can make. Okay, so we're here. Oh my gosh!
So, thank you, Kevin Lubin, for setting this up.
The amount of awesome this is right now is so high I don't even know what to do with myself.
Okay, watch the flow tank.
Yeah,
Yeah.
nice.
We should play this on the
Like as we're testing our software and that links in video. See, I was just looking through all the VIs and it's a Star Wars actuator. Because I was looking for sound. It's like some sound read or sound file or something. And it's Star Wars actuator. Awesome.
Attached to each tank are pressure and temperature sensors that give us another method of measuring how much water is in each tank. Between measuring how much water we put into the flow loop, the data from the flow totalizer, and our pressure and temperature readings, we can know whether or not our measurements from the sensors are correct. Then there is the wiring, which connects the various components through the bulkhead connector, through the secondary containment to the power amplifier, a power source, or the DAQ. The DAQ, data acquisition, then connects to the computer, where the software can tell specific components to turn on or off, as well as generate the white noise and record and analyze data. The computer records what the sensors are taking in, and the program analyzes it as we go to allow us to see our results in graph form during the flight. It is from these graphs that we are able to decipher how much liquid is in the tank. Sounds pretty cool, right? And what's even cooler, we're headed to Houston next week, which means we're one step closer to testing the experiment on the zero gravity plane. So stay tuned for more videos of us in Houston. Don't forget to follow us on Instagram and Facebook. Tweet us with questions at Carthage USIP. See you guys next time from Houston!
How it's set up is when it gets to the end of the song, the code will die again.
We just played the Mario theme song on this.